I'm going to do that, yeah. Okay, so for this one, for number 1, I think you've got a bullet going along here at 890 meters per second, right? It's 78 grams, so it's 0.078 kilograms, right? And then here's a block of wood, and here's a block of wood, right? And then I imagine the next frame, the bullet has gone through the first block, is twixt the blocks, yet has not struck the second block, right? And then in the third frame, I believe that the bullet has gone through both blocks. And here it's going some velocity, right? And then following this, the first block, so it goes through both blocks. The first block's going 7 meters per second. The second block's going 4 meters per second. We're not to argue why, why it goes different velocities, right? We're just given that, right? And the first question is, what's the velocity of the bullet after going through both blocks? I'm going to set this picture equal to this picture, right? So I'm going to say 0.078 times 890 equals this picture here, which is, what is this? 400 grams. So these guys are 0.400 kilograms, right? So this is 0.400 times 7 plus 0.400 times 4 plus 0.078 times V, right? So this guy, this picture here equals this picture, and then we can solve for V. So this thing here, 0.078 times 890, this is 69.42. Right? This guy here is, what is that? I should be able to figure that. 2.8, is it? Right, this guy is 1.6, is it? I don't trust myself here. 2.8, right? And then this guy is, so I'm going to go this guy minus this, right? So 69.42 minus 2.8 minus 1.6. 65.02 equals 0.078. Right? So divided by what answer do we have on the sheet? 834, that's good enough, right? Ta-da. It's like nobody's paying attention to me, that's okay. This is normal. And then B says, what was the bullet's velocity between the blocks? Okay, for that one I'm going to set this momentum equal to this momentum. So this guy, I'm going to say, this guy is 0.4 kilograms, right? And so I'm going to say this equals 0.400 times, and then here we know it's already going 7 meters per second because the bullet's already gone through it, right? So this is times 7 plus 0.4. Whoops, I'm sorry. The bullet's mass is 0.078 times V, and we don't know what V is, right? But this is our expression, right? So again, that's going to be this guy here, the 0.078 times 890. 8 times 890. It still equals 69.42. This is 2.8, right? So minus 2.8 is that divided by 0.078, 854.1. And we got 854, yeah? And then C says, how much kinetic energy did the bullet have before entering the first block? How much did it have after it went through the first block? So let's see, this is our velocity here, right? Here's our velocity before, yeah? Okay. And the question is, you know, I don't remember this question from the test, but maybe it's there, right? So the physics.
Hey, Barry.
Hey, come here, Perry, come here. Just come here. Walk out here.
Harry, come here.
Just come here, come here. Just come here, come close. A little closer. Come close. Turn left. Wave. Say hi, YouTube. Okay, now go.
Hey,
He's like, he knew. Okay, so this kinetic energy here before the collision is going to be 1/2 mv squared, right? So it's 1/2 0.078 890 squared, right? So I'm going to store this number this number here is in my calculator. I'm going to store that because I know I'm going to need it. Okay, so I'm going to go 0.5 times 0.078 times 890 squared. And this is 30,891.9 joules. Does anybody have airsoft guns?
Yeah.
Do they rate them in joules? Yeah, they got feet per second, but they also talk about like how so many like, yeah, it's like joules, right? They talk about joules, right? I'll bet it's less than 30,891 joules. Yeah, I'm pretty sure this would shoot down like an airplane or something like that. Okay, and then afterwards, it's going to be the bullet's kinetic energy is going to be 1/2 mv squared, right? And then I'm going to use this 854.1. Only I'm going to use the unrounded version in my calculator because I'm suspicious. So that times 0.078 times, I'm using alpha A squared. And this is 28,450. 0.16. There we go. So here's before, right? Here's after it goes through the first block, right? And so it'd be interesting. I wonder on the test. I'm wondering what this question's like, and I'm just wondering because, you know, and I wonder if there's a way to tell what's on the test because there's never. It's always hard to say, right? You know, I'm just going to try to see if I can figure it out by just remembering. Kinetic energy. Oh, yeah. That's a hard question. Let's cheat even more. I'm going to tell you even more about what that question's about. And then it says kinetic energy before and kinetic energy after, didn't it? Didn't it say that? Okay, so what if it asked how much did the bullet lose going through the block? How would you do that? Would you subtract these two numbers? Yeah. Okay, so hold on. So I'm going to subtract this number. I'm going to subtract that number from this number, right? So that's an exclusive to you guys and anybody who watches this video. The question is how much does it lose going through the block? Okay, so I'm going to go 0.5 times 0.078. Physics. I thought that was Perry. Okay. And then the amount that this loses, not that I'm not saying that that's what's on the test, but maybe it would be, right? Is 2,441.7 joules lost. Right? Like